Okay, so we're going to go over 3.2 and we're going to do a couple of random problems. Actually, it's up here. We're going to start with number 9 and then move to 10 and 14, and they're all linked with these functions here. So here it just says to complete the tables. And so all they want you to do is literally just plug in. Okay, so they literally just want you to plug in. Because I know what's coming next, I'm going to do it on a on Desmos because I want you to be able to see how these are all linked. So go back to Desmos. So I'm going to plug all of these in here. Let's scooch this over just a tad. Okay, so I'm going to add these using tables just so that it'll do this. And so I'm going to use -1, 0, 1. Okay. And then here I'm going to plug in X. So I'm just going to go X. And then it's like, what are you talking about? So I'm going to do X sub 1. Oh, it didn't like that, huh? Oh, it doesn't like that. That's weird. It doesn't like that. Okay, so I'm just going to ignore that. And I'm just going to plug in. That's weird. I didn't realize it wouldn't let me do that. All right, so if I plug in -1, I get -1. If I plug in 0, I get 0. And if I plug in 1, I get 1. That one is not so exciting. Okay. For my next table, I'm going to do this one. And I'm going to use the same values, -1, 0, and 1. And over here, I'm going to plug in X to the third. And what do you notice happened? What do you notice happened? What happened? Let me turn this guy off. Turn this guy on. Boop. What happened? What happened to that? Hold on, I'm getting onto the page on my iPad. Yeah, they overlap. They're exactly the same, right? And that makes sense because look at our values here, right? So let me just fill in my values real quick. -1, 0, 1, -1, 0, 1, which makes sense, right? Because -1 to the third is -1 times -1, which is 1 times -1 is -1, right? These values are exactly the same. And again, I'm going to do this to my third table as well. -1, 0, 1. And then I'm going to go here and I'm going to go X sub 3 to the 5th. And there it goes. Oh my gosh, look, all the values are the same again. Oh, that makes sense, Miss Johnson. It makes sense why these values are all the same. Because we have odd powers, when we're multiplying -1, 0, and 1, this is what we get, right? So if you look at these three dots are exactly the same. Notice these functions are not near the same. X cubed, X to the 5th, very different functions. So then here, question 10 says, okay, well, what does it mean for those functions to be equal? Well, so I would continue, right? Let's actually graph those functions just so that you guys can see what I want you to see. And what do you notice between these three functions, between green, purple, and black? What do you notice about those functions? Number one, they're very different, right? The X cubed and the X fifth kind of looks the same-ish, right? They have that same kind of like shape, right? But it's a little bit different. And if I zoom in a little bit, you'll see how the purple and the black are kind of coming apart, right? It looks like a little split end there, right? There's a split there. Okay. So what does it mean? This is the question here. What does it mean when f of x equals to g of x equals to h of x? Graphically, what does that mean? What does that mean? Yeah, it means they have the same, that's where they intersect, right? That's where they intersect. So I'm going to write that down. That is where the functions Intersect. Very good. Okay, so when they intersect like this, it'll show up there eventually, right? When they intersect like this, algebraically, this is what it looks like. -1, you get -1. -1, you get -1. -1, you get -1. See those 3 points? They're all right here. Boom, -1, -1. 0, 0, 0, 0, 0, 0. There, that's where they intersect again. They come back together, right? And then last but not least, 1, 1, they all have the point 1, 1, right? And so it means graphically, that's where the functions intersect. Algebraically, it's where the points are the same, right? Okay. Okay, so then our next question is 14, and it says use the graph to graph this. So again, the same functions, x cubed, and x to the 5th on this interval from -2 to 2. From -2 to 2. Okay, so you want me to just go from -2 to 2. So I'm going to now use these guys here. And I'm going to use this, and I'm going to say -2 less than x less than 2. Oops, I did that wrong. Did I? No, I didn't. And then I'm going to copy this, and this is basically saying I only want to look at the function from here to here. That's what this language is saying. Only, this is the domain it's saying. Only look at my values from -2 to 2. That's it. Okay. So if you see here, right, let me zoom out a little bit. Notice that black one keeps going because it hasn't hit the 2 yet, right? But my green stopped pretty within the window that I can actually see. Same with my purple guy down here. Okay. So what they're really trying to show you that in these 3 problems, 9, 10, and 14, is just because our points are the same doesn't mean that our functions are behaving the same in between those points, right? Here they hit, here they hit, here they hit. In between those two, we have no idea what's happening unless you actually know the function, right? So like in like a real world scenario, that means like, I don't know, maybe me and you, like we bumped into each other at the coffee bean and we're like, oh, that's cool. Coffee bean. And then we bump into each other again, like, I don't know, 2 or 3 months later at a different place. I don't know. I don't know why my brain is thinking about ice cream. So an ice cream shop, me and you bump into each other. We're like, what? And then in between that, we bump into each other again. It does not mean that we were together the whole time, right? You could have been this, the purple function and you're like, woo, yeah. Or I could have been this green function, like boom, boom, like, doesn't that make sense? So it doesn't mean we were following each other the whole time. It just means our paths literally crossed at those points. In between those paths, it could be a very different story. Does that make sense? Very cool.